I really like this particular lab because it shows you so much of what's going on with routing behind the scenes and seeing it hop by hop. And the real thing we're seeing right now is, of course, like I said, our pings still aren't going through, but our packets are leaving router 3. And the reason I was so enthused there at the beginning is that I'm really excited about what this is about to teach you because this is so important and it really differentiates regular network admins from world-class admins. And that is this: you can't just concentrate on one device. It's great to look at one router. If there's a particular issue, maybe with something you just configured and something went wrong, then yes, the problem is probably on the local router. But as a world-class network admin and as a CCNA, you can't look at one piece of the picture. You've got to look at the entire picture. So what the heck am I leading up to with this? Well, here's where we are right now. And we know the ping to 2222 is failing from router 3. But the thing is, it's not enough for router 3 to have a route to that network because it does, and the pings still aren't going through. The downstream router, in this case router 1, also has to have a path because right now if router 1 goes up and pings 2222, I mean nothing's going to happen. And we can go right up there and see that in action. And actually, let me do a debug first and then send ping. And what are we going to get? The exact same thing we had on router 3 previously. We're getting unroutable messages. And this is why I love this debug. I don't want to scare you from it because it gives you some great information, especially in a lab and a practice exam environment, and it tells you exactly what's going on with the packet. Because again, with the pings, we send those and it's a great first test. But the thing is, we don't get anything after that. You know, are they leaving the router? Ping doesn't tell you. Are they unroutable downstream? Ping doesn't tell you. But debug IP packet really helps to give you this information. Now we got to have a way for router 1 to get packets to 2222. And ordinarily I would write a host default route in this situation as well, but we've already done that in a previous video. So what I'm actually going to do here is write a default static route, show you the syntax for that, show you what it looks like in the table. And let me do a quick show IP route here again, and you can see still the only route we have is a connected route. So I'm going to write a default static route here, and this is the kind of syntax. You know, you have to get over this when you first start studying Cisco technologies. But some of the commands just look funny. It's just no way around it. You know, you're looking at something that's like, look at all the zeros. Can that possibly be right? Well, we're going to have a lot of zeros in this IP route command because when you are configuring a default static route, you're still going to use the IP route command. You're going to use an IP route command for a host default, a regular default, static default like we're doing here, a regular static and then a static default. And you're also going to use it for floating static route, which we're going to write a couple sections from now. It's just for our default static route, this is going to look a lot different. And we're going to put all zeros. Remember, let me show you iOS help. This is our destination prefix. And the destination prefix is all zeros, and then so is the mask. And you still have to end it with either the local exit interface or the next hop IP address. I'm going to use 172.123.2. And that is it. And in case I had not mentioned this, we do have some options here that you'll see in later studies. But when you see that CR down here, stands for carriage return, which is a fancy way of saying enter. And that's just simply to indicate to you that what you have in here is a legal command. And notice up here, when I used iOS help to see the interface types and see the options at that point, you don't see a CR here because it's not a legal command yet. But we do have a legal command now with IP route. So I'll go ahead and hit carriage return and hit enter. And let's see what the routing table looks like now. Big difference here though in the code. We don't just have an S, we have an S asterisk. Anytime you see that little asterisk over there, whether it's next to an S or next to another letter, that is a candidate default route. And if it's the only candidate default route you have, that is your default route. So when you see S asterisk, that means someone has written a static default route on that router. And you'll also see this, gateway of last resort is, and there's the next hop IP address we put in, and it's going to say to network all zeros. Now, when we think of the word default in computing, what do we think of? We think of the first thing, right? Well, this is going to happen unless we change something. Default route sounds like the route that's going to be used first to some. And let me clear it up for you right now. The default static route, it really is what it says right here, the gateway of last resort. It's the last resort route. So basically, when you have a default route in the table, the router is looking for a match. It's looked through everything else and says, okay, I don't have a match for this route because there is no match in this table for 2222. There's only one other entry anyway, and 172.12.123.0 is definitely not a match for 2222. So then the router is going to say, okay, I've got a default static route. I've got a gateway of last resort set. I'm going to send these packets to 172.12.123.2, and then that's going to be it. So let's go ahead and send our ping first from here. And they went right through, no problem at all. And let's go back to router 3 now after all of this. And we've had some great lab work here. You've gotten to see how the routing works and a couple different uses of IP route. When we're at this situation now, we've written a host default route on router 3. We've written a default static route on router 1. Will this ping go through now? From router 3, that is. I think it will. Ta-da! And there it goes. And you'll also notice again when router 1 pinged that address, what the round trip time average was, and then what it is from router 3, because the traffic from spoke to spoke has to go through the hub. Absolutely. Well, this might just lead you to think, you got that default static route down and, you've got some other uses for default static routes. Why don't we just do this and just forget about the dynamic routing protocols? Why do we use RIP? Why do we use EIGRP? Why do we use OSPF? We're going to talk about advantages and disadvantages of static routing coming up next.